structural engineer from the Faculty of Civil Engineering of the University of Buenos Aires. First of all, I want to thank CADC for the kind invitation to give a conference at this important event. The English language is not my native language. I will try to do my best to be able to give a useful conference. The title of the conference is Construction Process of Precast Elevate Viaducts and Bridges as a Response to Speed Up the Evolution of the Construction Industry Due to the Pandemic. I will briefly provide concepts about the design and construction of bridges for rail and road uses. Finally, I will provide conclusions and opinions on how to improve the construction practices of these structures, especially the use of the ABC construction method to face the new challenges that emerge in the post-COVID area. Structural design. Having elected the construction of an elevated viaduct from another alternatives, the structural design and construction are mainly determined by advantages and disadvantages between casting place versus prefabricated construction, casting yard availability, transport difficulties, width of the deck, roadway or railway geometry, accessibility of direction equipment, placement of the project, rural, urban, or mountainous zone. Piers and foundations. Piers, in general, rectangular or circular RC concrete columns, bents, RC or PT concrete caps, and two or more columns. Shallow foundations or group of piles, closed or open abutments. Decks, construction method, between 30 meters up to 50 meters span length, precast systems, and between 70 meters up to 300 meters casting plate methods. Static systems, continuous or simply supported. Main and erection systems, full span, span by span, balanced cantilever, incremental launching, and progressive placement. Main canal sections, U-girders, box girders, multiply I or U beams, plus cast in place or prefabricate deck slabs. Section depth, constant between 30 meters up to 60 meters span length, and variable between 70 meters up to 300 meters. Erection equipment, launching gantries, cranes, movable scaffolding, lifting frames, for travelers, and launching shacks. Precast systems, segmental span by span and balanced cantilever by launching gantries, lifting frames, or cranes. Full span by launching gantries, incremental launching by launching jacks and steel noses, U or I beams by girder shifters, and cast-in-place systems, segmental balanced cantilever by formed travelers, and full span by mobile scaffolding. Economical span length ranges, concrete bridges. Slab or T up to 20 meters span length. A girders between 20 meters up to 50 meters. Incremental launching between 30 meters up to 60 meters. Span by span system between 30 meters up to 50 meters. Balanced cantilever precast system between 40 meters up to 110 meters. And cast in place system between 70 meters up to 300 meters. Usual cross sections. Unicellular box girder, U-girder in segments, U-beam plus cast in place or precast decks panels, and mixed concrete steel box girders plus cast in place slab or deck panels. Composite action. Single or double composite action. Less usual cross sections, multicellular concrete box girders, all of this. When the width of the bridge is necessary to be high. PT concrete box girded with corrugate or trusses steel webs. Concrete, the upper slab, concrete, the bottom slab, and webs with corrugated steel or trusses. Optimum span ranges for different cross sections for railway viaducts. Ratios between span length and depth of the cross section. Slabs, concrete box girders, mixed girders, steel sections, and simple or double mix actions. Cast in place concrete deck or prefabricated concrete deck, U-beams, and prefabricated decks or cast in place decks. Some important details. Balanced cantilever and continuity PT. Shear keys, bottom continuity tendons, cantilever tendons, bottom PT bars, all of this for the cantilever system. Span by span with external or mixed PT. Mixed PT, external PT. For simple support or continuous systems. And then transverse PT in deck slabs, diaphragms, webs, and deviators. These are the main construction details for balanced cantilever and span by span systems. Construction, cast in place versus prefabrication. Precast cement erection, balanced cantilever erection with launching gantries, span by span erection with launching gantry, balanced cantilever erection with lifting frames, balanced cantilever erection with cranes, precast beam method, full span precast method, span by span erection on false works, and in situ construction, incremental launching, and form traveler method. Precast segments. launching gantry. Span by span with launching gantries, span length between 30 meters up to 50 meters. Balanced cantilever with launching gantries. Segments, balanced cantilever, launching gantry, span length between 40 meters up to 110 meters. Incremental launching between launching jacks and steel nose. Span length between 30 meters up to 60 meters. And progressive placement of segments with cable stay system or temporary piers. All of them are segmental systems. Precast full span with launching gantries. Span length between 20 meters up to 50 meters. U-girders, box girders. Cast in place segmental with form travelers, usually used in balanced cantilever method, between 70 meters up to 300 meters span length. Cast in place, full span, with movable scaffolding system, this machine. This overhead girder holds the scaffolding system between 20 meters up to 70 meters span length. Single beams, precast single beams, A and U, with girder shifter, the girder, and then cast in place slabs or precast deck panels between 20 meters up to 50 meters span length. This girder can shift the beams. Construction cycles, main erection methods. It is very important to estimate the construction cycle of a single span in order to determine the needs of the storage yard, precast construction buildings, and number of molds. Construction facilities and equipment. Precasting yard, segment transporter between the precasting yard to the bridge, to the placement of the bridge. Precast construction building, segment and molds, and lifting frames to transport segments into the precasting yard. All of these are construction facilities and equipments. Full span molds, U section, and box girder section. Long line and short line precast method. Construction system by conjugated segments that ensure correct fitting in straight or curved spans during the erection. Main erection equipment. Launching gantry for span by span. Launching gantry for full span. Cast in place full span with movable scaffolding. Cast in place segmental with form travelers. And incremental launching with launching jacks and steel noses. These are the main erection equipment and systems. Accelerated bridge construction. Based in prefabricated bridge elements and systems. Easy transport and fast erection. Improve in-place construction, total construction time, and public security. And reduce traffic perturbation, in-place construction time, and climatic issues. This method, in my opinion, is very important for the post-COVID area. Prefabricate foundations, prefabricate columns, prefabricate segmental columns, bent caps, walls for abutments, caps for abutments, in-place connections. All of these are prefabricated bridge elements that should be connected by in-place. Seismic PV connections, energy dissipating connections, ultra high performance concrete, superelastic shape memory alloy, and self-centered columns in order to achieve the performance-based damage states. In-place connections, mechanical bar connections, growth ducts, pocket connections, socket connections, and two-stage integral pier cap. All of these are in-place connections of the PVs. And finally, precast decks. Full or partial depth concrete panels connected to PT concrete or steel beams. Well, now I want to show you two viaducts constructed in Buenos Aires. The first one is called Mitre. It is a 4-kilometer length viaduct. The erection system was span by span. It's a railway viaduct. The section is a box girder, a concrete box girder, with external and mixed PT. Here you can see a segment, a mold, the casting yard and the segments storage, the launching gantry, and the construction finished. The second one is a 5-kilometer viaduct in Buenos Aires too. It's a railway viaduct too. is called San Martin. In this case, the direction system was full span. It is a concrete box girder with internal PT. Here you can see the self gantry, launching gantry, and the self-propelled transporter. And this is the construction finished. Improving construction practices, processes, and guidelines in post-COVID world. Conclusions and opinions. New bridge and viaduct constructions and retrofitting of existing structures are highly relevant activities in public works all around the world. In many countries, the public work construction industry can quickly help to reactivate their economies. To achieve this objective, the sources of financing through multilateral credit and development banks, fundamentally in development countries, is a crucial issue. These important infrastructure projects employ a large number of people, project, production, and management, architects and engineers, suppliers, construction workers, administrative staff, etc. The ABC method of bridge construction can be a valuable tool in safety and overall care within the construction industry. Prefabrication is prone to further organization, planning, and control of all types of activity relate to the industry and particularly with the mitigation process of this problem. In addition, the work in place in systematized processes, basically of transplantation and assembly of precast elements, are also prone to being able to comply with the OSHA recommendations. These systematized construction processes, in general, have greater facility in feasibility and financing analysis along with the compliance of the budget with limited deviations. This premise can mitigate the great risks and challenges posed by the post-COVID era. Maintenance and management of workforces, human resources, financial sources and financial health of the construction companies, recovery and stabilization of the supply chain, improvement of safety and overall care within workplaces. Well, thank you very much for your attention. I would like to thank CADC again for the invitation to give this lecture. It was an honor and a pleasure for me to have done it. I also want to thank the assistants for their kind attention, hoping you have found the conference interesting. Best regards to all Indian people and